Right. The definition of our Riemann sum goes like this. First, f it is defined on the closed interval, and that closed interval goes from a to b, and the delta is a certain partition from, we'll call that delta x, from a to b. Remember, a partition just means our width. And inside a to b, I start at a, I'm going all the way to b, and I have all of these different partitions or subintervals. A is equal to x sub 0, b is equal to x of n, and inside here I have all of these different values for x. Now, somewhere inside that interval, I have this point C. This would be C of 1. This would be inside this first interval. Inside my second partition, this would be C of 2, so on, and then all the way over here, this would be C of I. Now, how do I find each of those? Well, if we think back and we go ahead and we draw a curve inside here. If I'm just talking about this first piece, and I want to go ahead and use the right-hand method, what do you have? What would C of 1 equal to be? Well, C of 1, we first have to add in that A because we're not starting at 0. Then how wide is that particular partition? Well, that partition just has a plus delta x. Well, what if I come over here though? That's just for C of 1. If it was C of 2, still not starting at 0, right? So I'm starting at A, but I'm going over how many partitions? Delta x length has a width of delta x, and then I'm going over again here, the second one, so that would then give me what? That would give me 2 times delta x. So our general formula then for C of I is going to always be whatever my A is, plus I, the interval that I'm in, times delta x. And we need that going forward. And this always has to be a closed interval. And that closed interval goes from A to B. This is my lower limit, and B is always the upper limit. So to rewrite this with the limit definition, what we have here is the limit when delta x goes to 0. Again, that means when the width of the rectangle goes to 0, of the summation of I is equal to 1 to n of f of that sum point in the interval, c of I, times delta x of I. So there's some interval inside here. For all of the different pieces, where this is x to the n minus 1, this is x to the n, and somewhere inside here we have that value c, and this point on the top of the curve is f of c, and delta x. All right, so now we're going to go ahead and put it all together. Let's go ahead and label everything. So what do I know? I know that this is my upper limit, this is my lower limit, so b is equal to 1, a is equal to -2. I know f of x is equal to 2x squared plus 3. Now, the number of rectangles, I don't need to know that. I do need to know what delta x is. And delta x is just the same thing it's always been, b minus a divided by n. And again, I don't need to know the number of rectangles, so delta x in this case is just equal to 1 minus -2 over n, or just 3n. All right, that's the first step. The next step is to find out what c of I is, and we talked about that before in the last slide. C of I is just equal to a plus I times delta x. We just found delta x over here. We need that, and we have a, so I have a and I have delta x. So c of I is just equal to -2 plus 3 over n times I. Or I can go ahead and write that as just -2 plus 3n over I. All right, so the only other thing I need to find out with this is to find f of c of I, so let's go ahead and do that. So what is f of c of I? Well, my original function is 2x squared plus 3, so now I substitute in c of I for that. So then I get 2 times -2 plus 3n over I all squared plus 3. And if I multiply that out and simplify it, that gives me 2 times 4 minus, and this is just, I'm going to multiply those two together and multiply times 2. So that gives me -12i over n plus 9i squared over n squared plus 3. Then this gives me 8 minus 24i n plus 18i squared over n plus 3, or 11 minus 24i over n plus 18n squared I squared. So I just went ahead and minimized this. All of this is equal to f of c of I. So remember our function. I take my integral, I rewrite it as the limit when delta x goes to 0 of the sum of I is equal to 1 to n. And inside here, this is just going to be my f of c of I times delta x. Down here, this is f of c of I. And delta x we already found over here, 3n. So now we just have to go ahead and put all of this together, and I get 11 minus 24i over n plus 18i squared over n squared, all times 3 over n. The reverse of this is much less work. So we're going to go ahead and rewrite the limit when delta x goes to 0 of the summation of I goes to 1 to n of 3c of I plus 10, all times delta x of I, over the interval from -1 to 5. All right, so my integral symbol goes from 5 to 1. This is a and b. My integral always goes from the upper to the lower limits. Now inside here, this is my f of c of I. So that just means f of x is equal to 3x plus 10. So that comes inside here. And I need to make sure I have my variable, my dx, inside there.